Hello and welcome. I'm Deb, VCAN's Global Hygiene Specialist, and I'm here today to provide you with some information on metal detection and some facts on the uses and limitations of metal detectable plastics. So why is metal detection used in the food industry? Well, it's all about food safety and quality related to foreign body control. In most parts of the world, there will be a legal requirement to control foreign bodies, including metal, in food. This is the legislation for Europe, but there will be others that apply in different parts of the world, so please check your local requirements. Fortunately, most are based on HACCP or risk assessment principles. They may also be in standards related to audit requirements, and we'll look at these in more detail later. But one of the key issues related to the control of foreign bodies, including metal in food, is the impact it has on brand reputation. Headlines like these can be severely affecting a company's future business. Now, many customers believe that having a metal detector is a legal and/or audit requirement, but it will depend on the foreign bodies that need to be controlled. The two most commonly used global food safety schemes are FSSC 22000 and BRC-GS. Both state that the risk posed by foreign bodies should be assessed and controlled as appropriate. So, for example, FSSC 22000 states that, based on hazard assessment, measures shall be put in place to control, prevent, or detect potential contamination. It then gives a number of controlled examples, including the use of metal detections. BRC-GS also states that foreign body risk must be assessed and that equipment capable of detecting or removing the foreign body be identified. That doesn't necessarily mean a metal detector. Regarding metal detection, it does state that the metal detection equipment shall be in place unless risk assessment demonstrates that this does not improve the protection of the final product from metal contamination. For those of you that haven't seen a metal detector before, here are a couple of examples. And there are two main types. The first is called a balanced three-coil system, and this is the most common. It works by generating an electrical field which is disrupted by metal. So when a product contaminated with metal passes through the detector and disrupts the electrical field, it is then rejected from the line. The second is called a ferrous in foil detector, and this is used to screen products packed in aluminium foil trays or pouches, and this time the detector uses a magnetic field disruption to detect products for rejection. Now, very importantly, metal detectors are designed to detect metal. To make sure they do this as effectively as possible, manufacturers of metal detection equipment provide calibration test pieces that each contain a metal ball, either ferrous or non-ferrous, of a different size, usually 1, 2 or 3 millimeters in diameter. So, for example, here you have a calibration piece with a 3 millimeter non-ferrous metal ball inside. These are used to check the function of the metal detector. The settings on the metal detector are adjusted until the test piece containing the type and size of metal ball that is to be rejected is rejected when it passes through the detector. Unfortunately, it's not quite as simple as it sounds, because many things can interfere with the electrical or magnetic signals detected by the metal detector. So things like the physical and electronic vibrations created by other equipment. The food itself can generate an electrical signal, especially if it contains salts and water. And the speed of the conveyor belt can also affect the ability of the detector to detect and reject the correct product. Each detector will be different, so the calibration on the one won't be the same as on another. And the size and position of the metal contaminant in the food will affect its detectability, as will the type of metal it is made from, and so on. Consequently, the point at which the detection will occur will vary, even for a well-calibrated machine. And that means that even for metal detection, it is not 100% guaranteed. And as I said, metal detectors are designed to detect metal. So there are many other physical food safety and quality hazards that they won't detect, like stone, wood, bone, glass, and of course, plastic. So just to summarize some of the key points about metal detection technology and its use and limitations, metal detection systems are designed to detect metal. Many factors can affect their performance. Even when calibrated correctly, they are not 100% effective. And the use of metal detectors is not in itself a requirement of GFSI food safety standards, but there is a requirement to base their use on risk assessment. So what's the thinking behind metal detectable plastics? Well, many food recalls are associated with plastic foreign bodies, and here are just a few from the UK from this year. And although these recalls are generally associated with the unintended presence of plastic packaging material, they are more to do with food quality than food safety. They are still generating bad PR for the companies involved. Consequently, the food industry looks for ways to minimize the risk of rogue plastic in their products, and it's that interest that has led to the development of metal detectable plastics. So how detectable are these metal detectable plastics? Well, again, it depends on many things, including the type and quantity of metal detectable compound included in the plastic. This can vary enormously, but as a rule of thumb, the more metal detectable compound present, the better the detectability. Okay, you say, so let's just chuck a load of metal detectable compound into the plastic. Well, unfortunately, adding too much metal detectable compound can have a detrimental effect on the plastic, which we'll come to later. So it's a careful balance that's required. The size of the metal detectable plastic piece is also important. Even the best metal detectable plastics will contain more plastic than metal, meaning that you need a bigger piece of metal detectable plastic compared to metal to get a similar detection. I'll show you an example in a moment. The position of the plastic within the food or package is also important, as is how the metal detector has been calibrated. And there are still all of the other interference factors that I mentioned previously. As I've just mentioned, the type and proportion of metal detectable compound found in metal detectable plastics can vary enormously, and consequently so can their detectability. These are the results of a study that VCAN commissioned with Mettler Toledo, who are a leading manufacturer of metal detection equipment. They show the detectability of metal detectable plastics from various different equipment manufacturers. VCAN are in blue, and the other suppliers, 1 to 4, are in the other colours. Along the bottom of the graph, you can see the different sized pieces of metal detectable plastic tested, and up the side, the detectability compared with a 1.5 diameter iron sphere, shown here in the black bar. All tests were conducted without food packaging under exactly the same conditions, including the detector type, conveyor belt speed, sample position on the conveyor, and detector calibration settings. What you can see is that even for the same sized piece of metal detectable plastic, the detectability ranges enormously. Some metal detectable plastics weren't detected at all. So for supplier 2 in yellow, you can see that there are no yellow bars on the chart. And this is because supplier 2's test pieces didn't give any signal at all under these test conditions. In some cases, we had some very odd results, like this one, where a very small piece of detectable plastic gave a result which was 3 times greater than a piece of the same metal detectable plastic, but 27 times bigger by volume. This is possibly due to poor distribution of the metal detectable compound within the bulk plastic material. These studies were conducted on our original metal detectable plastic formulation, but the new formulation gives similar results. Appropriate calibration of the metal detector is essential to maximise detection of both metal and metal detectable plastics. However, it is impossible to calibrate a metal detector to detect both metal and metal detectable plastic fragments of the same size. For example, although VCAN metal detectable plastics were the most detectable in the previous study, an 11mm diameter ball of VCAN metal detectable plastic would be required to give a similar detectability to a 1.5 diameter iron ball. That's nearly 400 times the size by volume. Some manufacturers of metal detectable plastic equipment, including VCAN, provide metal detectable plastic calibration test pieces, and this is the one that we produce. These can be used in either of the following ways. Once the detector has been calibrated for metal detection, the metal detectable plastic calibration pieces can be used to determine the size of metal detectable plastic that will be detected under the same settings. These will be much larger than the metal fragments detected. If the metal detector is only being used to control metal detectable plastics, the test pieces can be used to calibrate the detector to reject the required size of metal detectable plastic fragment. For metal detectable plastics, the detectability of metal detectable plastics varies enormously. Selection of equipment made from appropriately detectable materials is crucial. Size matters. Metal detectable plastics are mainly plastic, so you need a bigger piece to get a similar detection to that of metal. An appropriate calibration of the metal detector is essential. So let's move on now to talk about metal detectable brush bristles. You may have noticed that some manufacturers of food industry cleaning equipment now supply brushes with metal detectable bristles. So why haven't we included these in our range? This is an example of a brush that you can find on the market with these metal detectable bristles, and these bristles are these grey metal detectable ones here. Well, it is something we've investigated by looking at metal detectable bristles' detectability, durability and functionality, and I'll share the results of these investigations with you today. So let's start with detectability and look at this in relation to different types, lengths and thicknesses of metal wire. So to achieve a similar result to a 1.5 diameter sphere of iron, we would need a 3mm long piece of ferrous steel with a thickness of 0.95mm. You can also see other examples in the table for copper and for part ferrous wire, where the length of the wire required is much longer. So you're probably thinking, well, yes, being able to detect a 3mm piece of wire sounds quite good. However, you need to bear in mind that most brush bristles are much thinner than the wire investigated. So the wire was 0.95mm versus 0.15 to 0.9mm for brush bristles. And that the metal detectable plastic bristle will only contain a small percentage of metallic material. So we can conclude that even longer lengths of metal detectable plastic bristles would be required to achieve the same level of detection. Okay, so just how long do they need to be? We got hold of some metal detectable plastic bristles of different thicknesses and lengths, and again asked Mettler Toledo to assess their detectability. This time we also checked their detection in different orientations on the conveyor belt and in the presence of no food, a dry food and fresh chicken breast. The detectability was again compared with that of a 1.5mm diameter sphere of iron, and what we're looking for was a reading of 1.8 or more for the plastic detectable bristles. Now you can see in red that most of the bristles were detected when no food was present, but as soon as you add food, none were detectable. Even the 0.6 thick 100 millimeter, that's 10 centimeter long bristle, wasn't detected. Consequently, the study concluded that metal detectable bristles were not detectable in the presence of food. Now let's look at durability. We gave some of our standard plastic bristles and some metal detectable ones to an independent external test house and asked them to assess the durability with respect to strength and elasticity of each type of bristle. They did this by clamping the bristle at either end of the special machine that you can see in the picture and measured the forces required to break the bristle as it was stretched. Let's look at the results. So these are the results for a 0.35 millimeter plastic bristle versus a 0.35 metal detectable bristle. The plastic bristle had a break strength of 27 and an elasticity score of 105. Don't worry about the units. Compare that with the break strength and elasticity score of the metal detectable bristle. These results show that plastic bristles were 68% stronger and more than twice as elastic as metal detectable ones. So it turns out that by adding more metal detectable compound, the more brittle the plastic becomes, and that means that the metal detectable bristles are more likely to break than the plastic ones and would actually increase the risk of product contamination. So what about functionality? Which cleans better, plastic or metal detectable bristles? Using the robotic cleaning rig in our own test laboratory, we compared the cleaning efficacy of a standard 0.35 millimeter plastic bristle brush with that of a 0.35 metal detectable bristle brush. All other factors, like the type and amount of surface contamination, the speed and pressure of the brush, the number of sweeps used, were all standardized for both tests. The results were based on visual inspection and showed no difference in the cleaning efficacy between the two bristle types. So in summary regarding metal detectable brush bristles, metal detectable bristles were not detectable in the presence of food. Plastic bristles were more durable than metal detectable ones, being 68% stronger and more than twice as elastic as metal detectable bristles of the same thickness. And metal detectable bristles were no more effective at cleaning than plastic bristle brushes. So I'm sure you can now appreciate why we haven't included metal detectable bristle products in our new range. Despite its limitations, metal detectable plastics do have their uses, particularly for direct food handling where foreign bodies pose most risk. Consequently, we have focused our new metal detectable product range on food contact items. We have also taken the opportunity to make the range X-ray detectable as well as metal detectable, and offer it in 5 colours that are virtually identical to our existing core colours, in support of our customer requests and obviously our own advice to choose colours that are in contrasting colour to the product that you're producing, which will aid the visual detection of foreign bodies in the product. And achieving these virtually colour identical metal detectable products was a real challenge. Unfortunately, most metal detectable compounds give the plastic a grey tinge. However, our R&D team worked really hard to enable them to find a compound that gave optimum detectability, durability, and the lovely bright colours that you can see. And if you're still looking to reduce foreign body risks from plastic bristles, don't forget our UST range. Its unique, award-winning construction significantly reduces the risk of bristle loss, and you can find out more about that here. And you can also read about how it's helping Nestlé reduce their risk of foreign bodies This presentation was designed to help you understand the limitations and uses of metal detectable plastics. To help you further, I have summarised the take-home messages from today in the next 3 slides. So for metal detectors, metal detection systems are designed to detect metal. Many factors can affect their performance. Even when well calibrated, they are not 100% efficient, even with regard to detecting metal. The use of metal detectors is not per se a GFSI food safety audit scheme requirement, but the requirement is to base the decision on risk assessment. For metal detectable plastics, the detectability of metal detectable plastics varies enormously. Selection of equipment made from appropriately detectable materials is crucial. Size matters. Metal detectable plastics are mainly plastic, so you need a bigger piece to get a similar detection to that of metal. An appropriate calibration of the metal detector is essential. And for metal detectable bristles were not detectable in the presence of food. Plastic bristles are 68% stronger than metal detectable ones, and metal detectable bristles don't clean better than plastic ones, and they are only available in diameters greater than 0.35 millimeters, which may compromise cleaning efficacy when used with fine powders, including some allergens. Metal detectable bristles are only available in grey, which gives poor visibility in product. However, ultimately it will be for you to decide whether to use metal detectable plastic cleaning tools and utensils or not, based on risk assessment. If you need any further support in this area, we do have a couple of other publications on our website that might prove useful. We have a blog on foreign body control and a white paper on cleaning tool maintenance. And of course, you can always contact VCAN or myself directly if you'd like to. Thank you very much and have a great day.